The geography of California is largely the result of plate tectonics at work. The Golden State sits on two major plates, the North American plate and the Pacific plate, both of which are considered very geologically active. This boundary between the Pacific plate and the North American plate is a transform fault boundary, meaning the two plates are sliding past each other, in this case, towards the northwest. This significant transform fault in California is called the San Andreas Fault. It is around 28 million years old and estimated to be around 800 miles in length. The San Andreas Fault starts right around the Salton Sea in the southern portion of the state. It cuts through some of the most populated areas on the west coast, including Los Angeles and San Francisco. Because the Pacific Plate is moving northwest, Los Angeles will someday be adjacent to San Francisco and will continue to slowly move northwest after that. However, the San Andreas Fault only moves several centimeters in a whole year, so it will take millions of years for it to move that far north.
The San Francisco earthquake occurred on April 18, 1906 at 5:12 in the morning on a Wednesday. The areas affected by the San Francisco earthquake were the North Coast, San Francisco Bay Area, and the Central Coast. The magnitude was estimated at around 7.9. This earthquake was recorded as one of the worst, deadliest earthquakes in U.S. history, and the death toll to this day remains the greatest loss of life from a natural disaster in California's history. Soon after the earthquake happened, devastating fires broke out in the city and lasted for several days and destroyed thousands of homes. Up to 3,000 people died and over 80% of the city was destroyed. The Long Beach earthquake occurred on March 10, 1933 at 5:54 p.m. on a Friday. This took place south of downtown Los Angeles, but the epicenter was offshore southeast of Long Beach on the Newport-Inglewood Fault. The magnitude was estimated around 6.4 and had an estimated $40 million worth of property damage and resulted in 115 to 120 deaths. The deaths were a result of people running out of buildings exposing themselves to falling debris. The magnitude was considered medium, however, the significant amount of damage happened because of poorly constructed buildings causing them to collapse. The Selma earthquake occurred on February 9, 1971 at 6 p.m. and was a 6.5 magnitude, and most of its damage was in the northern San Fernando Valley. The property damage was estimated to be $505 to $553 million, and the casualties were around 58 to 65 people, but left 2,000 people injured. The Northridge earthquake occurred on January 17, 1994 at 4:30 in the morning. Its epicenter was in Reseda, which is a neighborhood in the north-central valley, and had a duration of 10 to 20 seconds, leaving it as the highest ever instrumentally recorded earthquake in an urban area in North America. The magnitude was 6.7, and the death toll of this earthquake was 57 people, but left nearly 9,000 people injured. In addition to the high number of people injured, the property damage was estimated at around $13 to $15 billion, making it one of the most costliest natural disasters in U.S. history.
But that did not prevent us from reinforcing our structures with two innovations that have helped our buildings withstand large earthquakes. One construction method that we use for our buildings is to construct base-isolated structures rather than having a regular fixed base. In this method, bearing pads are placed in between the structure and the foundation, which would give the building more of a horizontal flexibility when the ground begins to shake. Thanks to the bearings, the building is able to maintain its rectangular figure, which means that the inertial force that causes mass damage to the building is significantly reduced. We have also implemented damping devices with a bracing system into our buildings. These bracing systems are placed into the columns of our buildings to give them more support against the horizontal movement that is produced from the earthquake. Columns are most vulnerable to horizontal movement because they are meant to withstand forces vertically. With this damp and brace system, the columns of our buildings are less likely to snap, which is what happens when a building topples over.
As you may know, the next devastating earthquake is commonly known as the Big One. These types of earthquakes typically occur every 200 to 300 years as massive amounts of energy move faults, which are usually stuck within the San Andreas Fault Zone. The Big One is described to be a magnitude 8 earthquake, and to put that into perspective, a magnitude 8 has about 30 times more energy than a magnitude 7 earthquake. Another important factor is that such a big earthquake releasing that much energy will cause a magnitude 7 aftershock that will even affect Mexico. Not only that, several big aftershocks will most likely hit in the following weeks and months. Moreover, Keith Porter of University of Colorado at Boulder predicts about 1,600 fires that would destroy 200 million square feet of residential property worth between $40 to $100 billion. The earthquake itself will cause about $50 billion, but the overall disruption caused from the fires and earthquake will total about $200 billion in a course of 6 months. Despite this, it is important to keep in mind that we are the most prepared we have ever been as a state. We have organizations and legislation, such as the Seismological Society of America and the recently reauthorization of the National Earthquake Hazards Reduction Program. Both provide invaluable resources aiding the federal and state government, schools, workplaces, and families regarding local or wide-scale earthquakes. Also, the big one is not happening tomorrow and very well cannot happen in our lifetime. At the very least, we should have or develop a plan because we cannot eliminate the possibility of an earthquake, but can absolutely reduce the impact.